Now this question requires us to look at again the range of values of x for which each of the following function is increasing. So again what I want to do is I want to find the f prime max in this case is because it's fx. We want to look at the f prime max. Okay, so over here, right, basically if you see that I need to look at the, let's consider expanding my fx, right? So fx here, let me write this. If I were to just expand it in index form, treating the square root as a power half, following which if I were to just expand the inside so that I don't have to do product rule when I'm doing chain rule, this gives me a negative x squared plus 13x minus 30. Okay, now from here what do I do next is then I'll go ahead to differentiate this, and because only by differentiating can we look at the f prime x and we can really check out whether the just give me a second, I'm just okay, then we can differentiate. So differentiating the outside, right, power goes to the front, right, just copy paste what is inside, then I differentiate the inside now in order, because I'm using my chain rule. That's a negative 2x plus 13, and with this, right, I see that my final f prime max would just be 13 minus 2x. Okay, I'll put a half at the bottom, and that gives me negative x squared plus 13x. Oh, sorry, no, plus 13x, yes, plus 13x, minus 3. Sorry, it shouldn't be 13x, it should be 7x. My bad here. Minus 30. So this is our f prime max. Okay, so now we want to see whether what are the range of values of x for which is the function is increasing. Basically is to look at where you want your f prime max to be positive, right? Because this increasing here suggests that you need your f prime to be positive, right? So from here, if you observe, right, the denominator, it will always be, it's a square root, so it's not negative. So we basically just consider the numerator, right? So what we want to do is we want to make sure that our numerator is positive. Now denominator 2 and square root will always be a non-negative term, right? However, you do need to consider that your denominator cannot be 0, because otherwise your fraction will be undefined. So not to forget that your f prime earlier, like when I expanded this section here, this is actually 13 minus 2x over 2 square root of, remember this part, 10 minus x minus the 3. Alright, so if you consider the denominator, now you must make sure that your denominator cannot be 0. It means that straight away, one of the limits that you must take note is x is not equals to, x cannot be equals to 3, x cannot be equals to 10. Okay, now for the numerator, you need this to be positive. So basically 13 minus 2x has to be more than 0, suggesting that x has to be less than 13 over 2. Okay, now if you consider the denominator again, because we are taking a square root, right? We are taking a square root. Now observe again, what's so important about a square root is that you cannot square root a negative term, right? So again, another constraint is that 10 minus x multiplied by x minus 3 has to be more than 0. Okay, now from here, just do the workup by yourself. The final answer you will get is that x has to be between 10 and 3. Alright, this is the constraint that comes from the denominator, because we cannot square root a negative term. Okay, so now if you consider all this, right, this is already considered here. Combining x less than 13 over 2 and x must be between 3 and 10. Now looking at the intersection of these two intervals, the final answer will be that x has to be between 3 and 13 over 2. If this does not not clear to you, then do actually work out a number line, and you can see why the intersection of these two intervals will give you this answer here. Okay. So next, let's look at B. Now, the trick for B is actually R formula, right? So actually for B, right, we do need to use R formula later on. Let me show you, right? So first of all, again, we find G prime X since we are considering our GX to be increasing. So finding the G prime X, that gives us negative sine X minus square root 3 cosine X. Okay, and remember that increasing means that we need our G prime X to be more than 0. Okay, so from here, now we are looking at like a trigo inequality, right? We need our G prime X more than 0. Basically, we need negative sine X minus square root 3 cos X to be more than 0. Alright, now the negative sign seems to scare people a bit, so let me just change it to positive. I'm going to multiply both sides by negative 1, and you see that I have sine X plus square root 3 cosine X less than 0. Okay, now let me simplify this further. Alright, I will change using R formula. This gives me 2 sine X plus pi over 3 to be less than 0. And this is one of the situations where you find that actually using R formula is so helpful, because it helps to change two trigo inequalities into one. Alright, so from here, what do I do next? Now if you consider if you want sine X plus pi over 3 to be less than 0, right, this will tell you that this is the same as having sine X plus pi over 3 to be negative. Now, if you need sine X plus pi over 3 to be negative, it will suggest one thing, that is you need your argument here to be inside the third or fourth quadrant, because that is the only place where your sign is negative. In the first or second quadrant, the sign is actually positive. Now, this will tell you that X plus pi over 3, right, basically has to be between, in the third and fourth quadrant, which is between pi and 2 pi. Okay, now from here, let's go on to simplify it. This means that X is between subtracting pi on both sides, pi over 3 on both sides. Okay, and you can see that in order for my sign to be less than 0, right, X must be between 2 pi over 3 and 5 pi over 3. Okay, so that is the answer for part B. Thank you.